Let's now take a look at the do loop. A do loop is very simple. We start with defining the do loop. We then execute a statement block, and then we end the do loop. So in our case, we would change our statement block to our write statement. Instead of Z employees, we will just output the word hello. See the pretty printer? Oops, look at that, making silly mistakes. Here we go. And as you can see, it's very simple. But one thing you might notice is that there's nothing telling this loop statement when to stop. Let's see what happens when we execute this code. As long as I put the proper full stop in place. So now we're executing the program, but see how it's stuck? This is because this do loop is processing thousands and thousands of times per second and outputting the word hello to the screen. So we're stuck in a loop, and that's not good for anyone. So we need to come back out and amend our code. So what do you think we need to do here? Well, we need to add some mechanism to this do loop to tell it when to stop processing the block of code in between the do and end do statements. And that's where we introduce the times addition. And the times addition would go straight after your do. So we would say 15 times, for example. And now when we test it, you can see the word hello is written out 15 times. Tell you what, let's stick it on the new line so it's easier to see. There we go. So the do statement is useful for repeating a number of tasks a specific number of times, but you must remember to always include the number and the times addition. Otherwise, you could end up in an endless loop, just as we did in the first example. So now I want to rewrite this do statement. Let's, instead of writing out, let's have some processing. Let's have a equals 0. Oops, wrong line. Do apologize. Let's define okay, so we define a as an integer. We set its value to 0. And then what we will do inside the loop is a calculation. A equals a plus 1. So this is just going to be a very simple counter. And what I want this to demonstrate is the do loop actually uses an internal counter to control how many times the loop is executed. You can check the sy index system variable to see how many times your loop has been processed. So let's do that. First of all, let's make sure we write out our own counter, and then we can compare it against the system counter. Everything looks good. I'll stick a breakpoint on the do, and then let's execute it. Okay, so now we're into the code. Let's step through it. I'm going to use the F5, single step. I'm going to double click on A so we can monitor that variable value. And what you need to have a look at as well when we execute the first one is sy index. And as you can see, that has a value of 1 as well. This is a system variable. You don't have to declare it. You just need to be aware of it. So let's execute the loop again. As you can see, as soon as we step into the loop, the SY index increases by 1 to indicate we are in the second iteration of this loop. Then our own counter gets executed and we write it out to the screen. And so on. And it will keep executing until it gets to 15. And I'll just zoom along. And there's our output. And once again, I should have stuck it on its own line. And there we go, all 15.